Good evening. I hope you're well. In this session, I'm going to discuss some of the aspects of exploring and tidying data before moving into data transformation. In our last class session, we examined how to connect to data, the connection types, how to parse and explore data, filtering data, specifically focusing on the power of a context filter. We examined sorting and discussed how nested sort is a default in Tableau. We wrapped up our last session by discussing how to clean a data set. Tableau has a built-in mechanism to automatically clean up and take care of some of the aspects of messy data. In this session, I'm going to discuss how to tidy data, union, and join. And then we'll move into discussion of data transformation. Moving into tidy data, which is one of these slides. Okay, here we are. So this is a phrase put together by Hadley Wickham of R fame, who has a number of R libraries, including ggplot2. Many years ago, he described a tidy data structure as one, where each variable has its own column, each observation has its own row, and each value has its own cell. This is not to suggest that data sets that are not tidy are untidy, but the name stuck. What has also stuck is, over the years, that the belief that, in general, tidy data sets are tall data sets. This isn't entirely true either. But Hadley coined the phrase, and many folks still think about tall data sets as being tidy. But I want to be very clear. It doesn't mean wide data sets aren't useful. But back to the point. In front of you are two data sets, wide and tall. The two data sets are identical in terms of the content they hold. They're simply represented differently. If you look carefully, you'll notice you can rearrange the content in the wide data set to arrive at the tall data set. If you were to move the data in the 2017 column under the 1960 column, you'd get a column that you could then call GDP. And then you can create another column, call year, which would hold the years. You'd recycle the three countries, USA, China, Japan, to create another three rows for them, thus getting a tall data set. As it turns out, tall data sets are far more useful for manipulation, analysis, and visualization of data. Hence, in most cases, if you're handed a wide data set, you may want to convert that into a tall data set. So we're going to examine how you can actually put this to practice by converting naturally wide data sets or data sets that are provided to us in a wide format into a tall format. To illustrate this point, I'm going to use a data set of New York City population. Given to us is a data set consisting of the population of New York City as a whole and its 5 boroughs. It also includes forecasts for the next couple of decades. Heading over to Tableau, I'm going to pull in this data set now into Tableau. The dataset called New York City population by borough is now in front of us. A couple of things about this dataset. It includes 22 fields and 6 rows, as it says in the small annotation above the table. Furthermore, you'll notice this dataset describes different levels of aggregation. It has data on the 5 boroughs, as well as the entire city. One may look at this and feel like it's redundant. Well, why would you want to do that? Well, yes, indeed. It is not common, or usually you want to make sure that your data frame or data set contains data of the same level of aggregation. So in this case, we would want to hide this row. You'll recall that in Tableau, you don't delete a row, but you can hide a row so that it doesn't interfere with other analysis or visualizations. To hide a row, we're going to add a filter on here, and we'll add a filter for borrow, and that's going to then remove New York City total. By doing this, we have filtered out NYC total as a borrow. Other things about this data that we may not want to keep. You have information here about the population for each decade, and also the share of the population of New York City. Given one, the other can be derived mathematically. So it's not adding new information. So in our case, we're going to go ahead and hide these columns as well, because they're not helping our table. So I'm going to go select these one by one. Since I'm on a Windows computer, I'm going to use Control and press down on Control as I click on these non-consecutive columns, non-adjoining columns. If you're in a Mac, you want to have Command press down as you multi-select these non-adjoining columns. Having selected all these columns, I'm now going to hide them by looking for the caret and then selecting Hide from the options. Now, if I drag the slider all the way to the left, there's one more column that we may want to hide. There's a column called the age group column. I'm going to hide this column also because there's nothing novel or new about the information in this column. It simply reiterates total population for every row. So I'll hide this as well. At this stage, we have data on the 5 boroughs, and we have data for every decade going from 1950 to 2040. Now, in its current form, the data set has 11 fields and 5 rows. It says that up here. It is a wide data set. In general, we usually want to have the data set to be tall, not wide. Because we usually want this data set to be rotated to make it tall so that now you'll have basically 3 columns. You'll have a column for year, a column for, column for borough, column for year, and a column for population. What I've done right now is select all the columns except borough. You can do this by depressing Shift. Select the first column, with Shift pressed down, go ahead and select the last column. You can do this with Shift because the columns are adjoining. Now I can go to the last caret here and select Pivot. What this will do is it'll make the data set that's wide, it'll make it tall. And let's see what happens. Here we are. We're now looking at 3 fields and 50 rows of data. I'm going to rename these columns to make them more meaningful. Pivot field names I'll rename to year. And pivot field values, again, I can rename by right-clicking here to population. There you have it. We now have converted a wide data set to a tall data set. Okay. Such data formats are more useful when it comes to conducting either data analysis or data visualizations. Let's look at one more example. I'm going to go and open up another data set out here. This data set is one containing product sales. Selecting product sales, I will go and open this data set. It's a CSV file. And so I open it up by selecting text file from the start page. This data set has 9 fields and 3 rows. It's clearly a wide data set. And I say clearly wide, but let me be a bit more guarded in saying that. What's wide and what's tall is really relative. There's no threshold for the number of columns that would lead one to say a data set is wide. one way I like to distinguish the two, wide and tall, that is if you can make a wide data set tall, well, then the original data set is wide. Some would argue you can make pretty much any data set tall if you wanted to. Well, that's true. If there isn't a way to make it tall, and then the data set you began with is wide. There's some no-brainers. If you have, a date or time variable along columns, then you pretty much want to make that tall because you typically want your year or any date-related variable in its own respective column. You don't want it, running across along the columns the way it is right now. Notice we have data for Q1, Q2, Q3, Q4. Okay. Now, similarly, product A, product B. I would rather have these in rows rather than have them as columns. Okay. So we're going to begin here by rotating this data, by pivoting it. Let's do that first. So as before, I'll go and select these columns from start to end. I can do this with Shift press down, and then I'll make this tall by pivoting the data. You can see that having done this, we now have 3 fields and 24 rows. Now, what we want to typically do here is, as you can see, we have this column that really contains 2 things, product and quarter. So I can deal with this by splitting the column into 2. It seems obvious that product and quarter are separated by a delimiter, the space. So by defining space as delimiter, we can use a custom split to split this into 2 halves, into 2 different columns. Here I'll say, under use a separator, use a space. Whereas the split off, I'll make that all. What has happened now is I'm telling Tableau that split these into 2 different into as many columns as you'd get by using space as a delimiter. Because there's only 1 space, we would get 2 columns from doing so. This would give us 2 new columns. You can tell they're new columns because they have an equal to sign next to them. Now, the original column we no longer need, so I'm going to hide that one. That's product AQ1, so we don't need that anymore. I'll hide that. Okay, and let's rename these remaining columns now. So pivot field name split 1 is clearly product. Pivot field names split 2 is clearly quarter. And lastly, pivot field values is clearly, in this case, well, this is sales data, so it's got to be sales. Okay, there we have it. We've got now a nice, tidy, tall data frame or data set. Okay, having looked at how to tidy your data, let's move on now to how to combine a large number of data sets. This is a process of enhancing your data by stacking them one on top of the other. Let's see how we can do this. So we're going to take some data, sample data here, and work with that. One data set we can use is Tesla Union. Let's go and find this file. I'm going to go to Tableau, and I'm going to read in a data set here called Tesla Union. I know this data set is a Excel file, so I'm going to go here and say data union, look for, I guess, union. And once I go in there, I'm going to look for Tesla Union. I'm also going to open this data set in a separate Excel spreadsheet so you can see what it looks like in Excel. Let me share that with you. All right, so here is the data set opening up in Excel, and let me pull that in front of you. Okay, what you're seeing right now is an Excel view of the data set. You'll see we have here very standard. If you're in finance, you probably recognize this as your OHLC data. It's open, high, low, and close data sets, stock values for stock prices for Tesla for each trading day of the year 2015. We also have the volume and the adjusted value of the stock for that particular period. The file contains data for each year from 2015 on till 2022. Okay. So this is how our data is organized. Now imagine wanting to stack these one on top of the other. You could do that manually. It's not impossible. You could do it. You would basically copy snippets like this one by one. So I'd probably go to 2016 and select all the data, copy that, go to 2015, go into that data set and try to paste that at the bottom, right? Something like this. And that's one way you could combine these data sets, assuming, again, the column headers and the column names are match up. Okay. But you realize this is a tedious kind of task to perform. And if you have more than, let's say, 50 or 100 such data sets to combine, it would be daunting, not just tedious, right? So this gets to be a headache. So instead, we're going to let Tableau do this for us. So I'm going to head over here to Tableau, where we're going to do the same exact magic using the Union option in Tableau. Now here we have our sheets on the left. These are sheets or tabs from the Excel workbook. I'm going to grab year 2015 and drop it onto our sheet. You can see now the same exact data showing up in Tableau. This data contains the dates for the different days of the year and also the OHLC data for Tesla. As you can see in the small annotation on top of the table, we have 8 columns and 252 rows of data, which represents the number of trading days in the year 2015. To perform a union, you could either drag 2016 onto the table like this. It's a manual process, but it works. That didn't work. Go back again. So as I added on 2016, we have 504 rows. When I add on 2017 as well, we should probably get more than 504 rows. There you go. We got 755 rows and so on. Now, this is not a method that I would recommend. So I'm going to hit the back button a few times so we can start afresh. Okay, so here we are. We have only 2015 in front of us right now. And I can confirm that it's only 2015 because it only has 252 rows of data. Okay, so you could hit this arrow, caret, and right next to year 2015, and select Convert to Union. Once you get to this view, you're now in unionizing mode. You could, again, if you wanted to, drag and drop, tables like this. Again, I don't recommend doing that because it's a very manual process. Instead, let's go to the wildcard option. The wildcard option enables us to combine files that have similar names or have some common thread across their names that would make them seem like they're related or similar. So I can go here and say matching pattern and specifically say whatever is common across all these different tabs in the Excel workbook. As it turns out, the common thread is the phrase year. So year underscore, if I use that year underscore there, it's going to kind of carry forward to all, right? So think about it again. Year underscore, and that would just apply to every single sheet here. What is missing out here, as the matching pattern says, is some sort of a wildcard character. So star is going to specify that we're going to accommodate any any sheet name that begins in year underscore and ends in something. Could be anything after that, right? So it could be a year, 2015, 2016, so on and so forth. Now, there are options here that I'm not going to select, but imagine your files or your tabs are spread across multiple subfolders. Or if you want to go one level above, you could do that by checking these boxes. So you could be combining, like, you could, identify like 1,000 different files with a consistent naming format, and you can combine them by using the wildcard option. Let me go ahead and hit OK on this one. When I do that, what happens now is um, we have, you'll notice 10 fields and 2014 rows. You'll see we've added on to more columns because Tableau likes to add on some sort of an identifier so you know where the data came from. This tells you data comes from this sheet, right? And that's the file path for it. Importantly, we have 2014 rows, indicating we have now got a lot more data than we had before. And that's unionizing or unioning your data, or the power of doing a union. The way we perform the union out here with Excel's tabs, you'd use the exact same methodology to combine CSV files in a given folder. So I have other data sets I've shared with you. You can perform the same activity with those as well. Moving along, we're now going to go and take a look at another way of combining your data together. This is called a join. Imagine you've got two data sets that you want to connect together using a common field. Well, that'd be called a join. Let me give you some context on this, though. Joins are most commonly discussed in the context of relational databases. Relational databases are characterized by a number of small tables that have some information in them. The thinking is that if you have one large file with a lot of data in it, it is going to have a lot of redundancies in it. Take, for instance, an illustration. I go to a certain restaurant and eat some food. Let me be more concrete about this. Vishal goes to Rosella's Pizzeria and orders 2 slices of regular pizza, pays $7 at, let's say, 5:30 p.m. on September 22nd, let's say. And in that row of data, along with my name, is also other information about myself. Let's say Rosales knows, hypothetically, they don't. But if they did know more about me, they would know things like, my address, my date of birth, send me a, gift card, my birthday, or a reminder of my birthday, something about my hobbies, my psychographics, et cetera. The next row of data would be Vishal, along with all my demographic data, all my psychographic data, went to Rosella's and ordered a slice of regular pizza and a Sicilian slice. Spend $9 at 5:28 p.m. on some other day. Third row, Vishalala. Same demographics, same psychographics, different pizza order. Fourth row, Vishalala. Same demographics, same psychographics, different pizza order, so on. By now, you probably get the idea that the information about myself, in this case, the customer data, has an obvious redundancy, is that it's repeating itself row after row after row, while the transaction data is changing or evolving. The thinking behind relational databases is to house customer data in one table and transaction data in another table. In this particular instance, the customer data would just be one row because it only has one customer's information. The transaction table would have as many rows, as many trips I've made to Rosella's to get pizza. Right? This makes it more compact, easy to store, and less duplication. Less duplication means less likelihood of, integrity issues in the data, inconsistencies, and so on and so forth. When the need arises, somebody wants to see all the data, we simply join them together. We join them together by typically a common field, some sort of field that identifies me, a number usually, like customer ID, and a similar identifier in the transaction file. The transaction file could also carry my customer ID to be able to connect the two tables together. That's how relational databases work, and the language SQL is frequently called upon to perform these joins. We'll be doing something similar here in the Tableau environment. So let me head over now to an example data set. So let's take a look at two data sets, and we will Um, we're gonna, uh, hmm, I'm thinking about how to do this in, in with Zoom going on, because I can only share one screen at a time. So let's see if I can make this possible. Okay, so the example I'm going to use involves two files. Let me see if I can do this uh, in Zoom with Zoom going on. So I'm going to take these two files I have open. I'm going to show you this one by one, and I'll combine them into one file so you can see the data side by side. So we have a file called customers and a file called transactions coming up soon. Um, so bear with me. Okay, so here is data on the customers, again, coming up in front of you shortly. Here we go. This is the customer's data. And let me make sure the columns are large enough, wide enough so you can see them clearly. Right, so here is some customer data. It's big enough. Okay, so notice we have here customer ID, blah, 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 all this information now. Imagine you have another table that I'm going to paste side by side. Okay, now this is not how it is in our data set, but I'll just paste side by side here. So you can probably just see the two tables side by side. Okay, so here two tables we have, right? So one of them on the left, this is our, and I'll color them so you can see the difference clearly here. Let's color this in. The one on the left is a customers table, and the one on the right is the transactions table. And let me do a thought experiment out here. So if I were in class in real time, I'd be saying the following. I'd be asking you the question, if you look at these two tables, customer table and transaction table, could you figure out how much money did John Doe spend at this store? You look carefully and you'd wonder, "Oh, well, did I know that?" And you'd probably figure out that the answer is 470.75. Feel free to pause the video and figure that out. Furthermore, here's an easy one. Jane Smith spent $100.50 on February 10, 2023. Now, if I ask the question, how much do you think Emily Johnson spent? You'd have no way of knowing. Because notice Emily Johnson is not represented in the transaction file, right? So given these two tables, you could intuitively find out, or figure out what is the amount a given customer has spent. You can find out about their transaction details in a sense. Um, of course, you couldn't find out transaction details for a customer like Emily Johnson who didn't actually shop or buy. Let's head over to, let me shut this example down here. Let's head over to Tableau now and see if we can illustrate, demonstrate to you how you can do a join. Again, to open a new file, I'm going to go back to the start page and click on text file. And now I'm going to go and open up a file called, let's go join customers. Here's customers file in Tableau. It looks like this. So here we have information about 5 customers and their email addresses. The transactions file, let's look at that. I'll pop this one out, put transactions in here, has basically 5 rows and containing transactions. Let's go back to customers file. Okay, here's the customers file again. I'm swapping back and forth there. Okay, now, before I go ahead, let me highlight one more thing about joins. Tableau doesn't do joins automatically. It does relationships automatically. So you'll see this in the cartoon out here in the background. It shows you how it's this noodle type line. And I'll show you what it looks like as I drag in transactions. If I try to connect it to customers, I get a noodle-like kind of line connecting the two. This means Tableau is trying to go into relationship mode. Now, relationships is the default in Tableau, but relationships are not a uh, you know platform agnostic way to integrate data. It's very Tableau specific. And so I'd rather go stick with and use something that spans different platforms. The idea of joins. Joins are implemented by many different platforms, many different software in a very consistent way. So rather than doing relationships, we're going to do joins. To ask Tableau to go into join mode, you must double click on customers. The gray border here indicates to you Tableau is ready to join tables now. To join another table to the customer's table, we will drag it and place it right next to the customer's table. Not below, remember, that was for union, but right next to it. When you put it side by side like this, you're now going to see a line show up connecting the two tables and two overlapping circles. You may have noticed what happened in the bottom also. We now have 7 fields and 5 rows rather than 5 fields and it's 3 fields and 5 rows or so. Now it's a little different. Okay, the shape has changed. Now let's review the data here. We have here John Doe showing up twice because, as you recall, John Doe has had 2 transactions, and that's why the amount he spent is like 570.75 or so. And you'll notice here that Emily is not represented here because she had no transactions. Now the reason that we're not seeing Emily here is because the kind of join we have implemented here is a default join, and that's because you see out here only the overlapping circle is shown, and that tells you basically that we're by default doing what is called an inner join. Right? In inner join, you only use common rows from the 2 tables. On the other hand, if you had done a left join, notice now Emily's back. You'll see Emily being represented here in the last row of the combined table. And what it means here is that if you do a left join, every row in customers.csv every row will be represented in the combined result. However, we'll only use rows from transactions that are also in customers. So we'll use the common rows in transactions, but we won't use, all the transactions rows in a sense. So, on the other hand, let's click on right outer join, right join. If I do right join, every row in transactions is represented in the final table, but only matching rows in customers are represented. And so again, Emily is again getting dinged. If you go with the full outer join option, now what it does shows you all the data from both tables, regardless of whether they match up across the 2 tables or not. Emily again is back, right? Okay, now for the last part, how are we connecting or joining these tables? What's the basis for linking them? If you said customer ID, you guessed right. Tableau will by default connect tables using variables with common names. It assumes if the variables have identical names, then they might have identical data as well. So you can see here it's connecting the 2 by customer ID by default. You don't have to, of course, go by the default. You could specify a different variable to join them based on. Right? Okay, so we have discussed so far how to conduct unions and joins. Let me take you to a picture here of a join or joins being conducted in another data set. So what you're seeing out here is a very complex structure. There are a number of different lines being drawn out here that show you how the different tables here are being connected. Within each rectangle are the variables included in the table. And along the lines are represented how those tables are connected together. You'll notice this particular instance that I've marked here is interesting because book ID and info are being joined by book ID from the left, but a combination of rows or variables from the right. So in this particular instance, we're not looking at a common variable to join them. Rather, we got to create a variable here to join it with. So in this particular instance, Tableau's default will not work. All right. So to sum up then, we have examined in the last couple of minutes how to tidy a data set. We've examined the process of unioning a data set or stacking data frames or data sets one on top of the other, assuming they have this similar structure. And lastly, we examined how to join different tables together. That's all for now. I'm going to meet you in the next session where we look at data transformation.